Hello, we've already learned about nuclear fission and nuclear fusion. In this video, we'll talk about yet another kind of nuclear reaction, the radioactive decay. If you have watched my video on the uranium-235 fission, you would know that many of the fission products are themselves unstable. So many of them will undergo radioactive decay. If you have watched my video on nuclear fission, you will have learned that in the supernova, a lot of elements beyond iron-56 are formed, and many of these nuclei are also unstable, so they also undergo radioactive decay. As far as the A-level syllabus is concerned, these are the three types of radioactive decay that you must know. Let's start with the alpha decay. The uranium-238 is an example of a nuclide that will undergo alpha decay. Apparently, the uranium-238 is not very happy about its own nuclear composition, so sooner or later, it will spit out an alpha particle, which is basically a very energetic helium-4 nucleus. See, the uranium-238 has lots of neutrons and protons, right? So out of all these neutrons and protons, it threw out 2 neutrons and 2 protons, packaged as an alpha particle. So we call uranium-238 the parent nuclide. After an alpha decay, we get an alpha particle and the thorium-234, which is the daughter nuclide. As in any nuclear reaction equation, the total number of nucleons and the total number of protons must remain the same. So after throwing out 4 nucleons, we are left with 234 nucleons. After throwing out 2 protons, we are left with 90 protons. That's why the daughter nuclide is the thorium-234. And so we are done with the alpha decay. Let's move on to the beta decay. We have a carbon-14 nucleus here. Carbon-14 is also very unhappy about its nuclear composition. So if we wait long enough, you'll see it spit out an electron. Are you surprised that a nucleus can spit out an electron? You should be, right? Because the nucleus only contains neutrons and protons. So where did this electron come from? Now I'm going to replay this thing a few times. You see whether you can figure out where the electron came from. Yeah, that's right. You see, this is a neutron here, right? During a beta decay, a neutron decides to split itself into a proton and an electron. So make sure you realize that the beta particle is not one of the orbiting electrons. It actually came from the nucleus. A neutron in the nucleus decided that it doesn't want to be neutron anymore. It wants to be a proton. And it achieved the transformation by throwing out an electron. That's why the number of nucleons remains the same, right? 14 nucleons before the decay, still 14 nucleons after the decay. This is because the neutron that splits itself into a proton and electron remains in the nucleus. So we still have 14 nucleons. But the number of protons has increased by 1. Which is why the elements has changed from a carbon to a nitrogen. The charge numbers also balance on both sides of this equation. 6 is equal to 7 plus -1. Okay, so that's the beta decay. Let's move on to the gamma decay. Why is this nucleus shivering? Now I'm trying to convey the sense that this nucleus is very excited. So many newly formed nuclei are in excited states. Maybe they have just been produced by nuclear fission. So because they have just been born, they have a lot of nervous energy. So to de-stress, they throw out a gamma photon. Get it? They had too much energy, right? How to get rid of those energy? They package it into a gamma photon and throw it out. So there's no change in the nuclear composition actually. That's why the A and Z number remain the same. But it's customary to put an asterisk here to represent an excited nucleus. So when it de-excites, it becomes a normal nucleus with a gamma photon thrown out. So that's it, the gamma decay.